volume of a cylindrical tin can with a top and a bottom. So pi r squared on the top and pi r squared on the bottom is to be 16 pi inches, or 16 pi cubic inches. A minimum amount of tin is to be used to construct the can. What must the height of the can be? So looking for height, but obviously there's also a radius involved. It tells us the volume. Pi r squared h equals 16 pi. But that's like the helper equation. That's the secondary equation, not maximizing or minimizing volume. The volume is 16 pi. What we're minimizing is the amount of 10. So, I don't know, 10 equals, that would be the area. It would be how much tin we're going to use. So, two circles, so 2 pi r squared. That's the top and the bottom. And then the lateral surface area, that's the fancy word for it. If you unfurled this can, it would have a height. And if I unwrapped this can, how long would this side be? That would be the circumference of the circle. Roll it out and we get 2 pi r. So, pi r squared times 2, that's the top and bottom of the can. And then the sides of the can, or the side, how many sides does a can have? I guess just one. 2 pi rh. That would be the lateral surface area. Okay, this is what we want to minimize. So that's what we need to take a derivative of. But why don't I want to take a derivative of it yet? Because there's two variables in there, and that would be yuck. So let's solve for one of them. It doesn't really matter which one. I say it doesn't matter. Like, mathematically it doesn't matter. Ease of use it might matter. Do you want to solve for h or for r? I know what I would pick. H. Right? That way you don't have to square root anything. H equals 16 over r squared. So in place of h, we will put 16 over r squared. Instead of calling that 10, I'm just going to switch that to area. That's what we're trying to minimize. I don't want to take a derivative just yet. Let's do one more algebra step. 32 pi. You can put it over r, or you can put r to the negative 1. Either one. I'm going to put r to the negative 1 because I think that's easier to take a derivative of. So a prime would be 4 pi r minus 32 pi r to the negative 2, or over r squared. All right, back up, big picture. What am I doing here? I took a derivative. What do I need to do with that? Set it equal to 0. Because where the derivative is 0, that means there's a critical point, and there might be a max or a min there. So let's set it equal to 0. So 4 pi r minus 32 pi over r squared equals 0. What would you like to do to solve that thing? It looks kind of yucky. Yeah, I'd multiply by r squared and get rid of the fractions. So 4 pi r cubed minus 32 pi equals 0. Now, hopefully, we're on the downhill for this thing. How many steps can I do at once? Move the 32 pi over. Divide by 4 pi. Oh, they were kind to us here. R is 2. We should be grateful that's not an answer, because probably people would pick that. Why is that not the answer, other than the fact that it's not a choice?
When you're looking for height.
Yeah, that's the R, and it asked me for height. So, R is 2. H is, there you go, H is 16 over R squared. 16 over 4 is 4. So a height of 4 would minimize the amount of can we have for a given volume. That maybe doesn't seem like it, but that's a real world problem there. If you're trying to, distribute a gallon of paint and you're making paint cans, well, you don't want to make a gallon paint can that's like super long and skinny. That's going to be a waste of material. Also, if you made it super flat like that, that'd be a waste of material. So it's like, well, where's the optimum can where I use the least amount of material possible and still sell somebody a gallon of paint? So you would have to go through the calculus to figure it out. But people do that. That's real world stuff. If you're manufacturing 1 million cans a year and you can save 2 cents a can, well, save your company 1 million times 0.02, $20,000. Saving 5 cents a can, you're saving $50,000, and now you've paid most of your salary for the year by one math problem. Other questions? Do we need to jump to 16? Is it 16, Garrett? Because there's like 14 parts to it, give or take. Was 15 a breeze? I think 15 is a breeze because 15 could be a no calculator.
Yeah, 15 is no calculator.
It's no calculator, but it's a polynomial, so the derivatives are not that bad.
Yeah,
and it's probably rigged to factor, right? So everything works out.
So for the test, are there going to be non-calculator and calculator FRQs and multiple?
Yes. Yes. So on the test, glad you asked. On the test, I will give you, if I can remember how we're going to do this. I'm going to give you both forms. You're going to start with the no calculator form on the floor, and you'll start with the calculator form and the calculator on your desk. Take as much time as you like. I'll give you some hints of, hey, you probably want to be moving on. When you think you're done, then you put your calculator on the floor and you are done with the calculator. You can't go back and forth. Oh, well, now I'll put this one away. No, once you make the decision to surrender the calculator is gone. Then you can grab the no calculator test and work on it.
Well, I'll just make it all one test. Easier.
Then you can still work on the no calculator test. You just won't have a calculator. So there may be things you can still do. You just won't be able to use the calculator. Does that make sense? So you start with both, but no calculator on the floor. And then at some point, when you're done with the calculator part, you basically trade. Your calculator goes to the floor, the no calculator test comes up, and you got the rest of the time to figure it out from there.
How many questions on each one?
So there's the calculator part. Again, you'll start with that. 6 multiple choice, 1 free response. And again, the free response is like the ones on the worksheet. So there's 4, 5, 6 parts to it. And then the no calculator part, 11 multiple choice, 1 free response. Again, a multi-part free response and a bonus. All right, let's do number 16. So we did an optimization, we looked at graphs. Now let's do a calculator problem with all sorts of stuff on there. All right, a particle moves along the x-axis with velocity. Okay, that's velocity. Between 0 and 2 pi. So I'm thinking that's my x window. That's velocity. Velocities are meters per second. Time is in seconds. What is the acceleration of the particle at time equals 2? So how do I find the acceleration at a given time? V prime or dv dt, either one. dv dt at t equals 2, or you said v prime at 2, like those, that's the same thing. I have a calculator. This isn't awful, like you could do that by hand, but good luck. But why bother? Volleyball playoffs tonight, so second e to the negative x sine of x, and I know I want to go 0 to 2 pi, make sure I don't miss anything, and I don't know if my y min and y max is a good choice or not. We'll find out in a minute. I would say that's not a very good choice for y min and y max. I want to see more than that. So my window I'm going to change to like negative 0.5 to 0.5. Is that even? Yep, that'll work. Ooh, it did go below the axis over here. That might be important. What? I'm going to change my Y window one more time. Try to zoom in a little more so that I can see that. I still didn't see that dip very well, but. All right, so how do I find the acceleration from my velocity graph? Second calc, take a derivative at 2, and there's my answer. That's all it takes. Negative 0.179. It does say indicate units of measure.
Meters per second squared.
You can go meters per second squared. If you forgot what it is, you can use dv dt.
Meters per second over second.
Meters per second. The velocity is changing at 0.18 meters per second every second. Is the particle speeding up or slowing down? Speeding up would mean V and A same sign. Slowing down would mean V and A opposite signs. Justify your answer? Well, I just did. So now we're ready to look and see. We already found A of 2. So A of 2 is negative 0.179. And in fact, the picture's already there on my graph. What's V of 2? For my purposes, what do I need to know about V of 2? It's positive. The V is positive. The actual value is positive. The slope's going down, but the V is positive. So what's my conclusion then? Slowing down. And I kind of already justified it. I guess I could point back to that and say they have opposite signs.
Wait, is it positive because it's above the x-axis?
It's positive because it's above the x-axis. If you wanted the actual value, you could get that. The value at 2 is 0.123. But you wouldn't really need to say that because you can tell from the graph that it's positive. And we know you have a graph, so that's okay. What is the average acceleration? Uh-oh, that sounds like algebra. That sounds like algebra rate of change. So acceleration is change in velocity. So I need the velocity at 2 pi minus the velocity at 0 over 2 pi minus 0. Now, that's not a safe stop. I mean, that's a good answer. It's just not quite a safe stop. You've got to plug in your answers there. Although you could safe stop it and plug them into the equation and not evaluate anything. Or you could You could use the calculator to find v of 2 pi.
Why did that start sounding like a fire drill?
Uh-oh. Why did it say v of 2 pi is not valid? I wonder if my window didn't quite go far enough. Second calc, value, 2 pi, there we go, 6.283, dot, 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 I want to make sure I get this accurate. V of 0, if I plug in 0, I'll get 0 over 2 pi. So, I don't know, it might have been better to... Oops, that's not what I wanted. Uh-oh. Now we got to get that 6.283 number back again. I didn't save it. I should have written down more decimals. 6.283, 1853. And then store that. That's still not it. Well, that's why I wrote it down. 6.283, 1853 divided by 2 pi.
That's just pi.
That's 2.
So you divided it by pi. You didn't type in 2 pi.
Oh, I didn't type in 2 pi. So it should just be 1.
2 pi is 6.2.
Yeah, because 2 pi is 6.28 whatever.
Okay.
So the answer is 1. Units of measure. Well, acceleration,
Meters per second squared.
meters per second squared. All right, part D. When is the particle farthest to the right? Oh, this is what the warm-up was. So looking at that, what am I looking for on the graph to know that the particle is farthest to the right? Good. V changes positive to negative. Right there. I don't know where there is. Second calc 0. So
Can you just type the number?
I could if I knew what the numbers were.
You could just guess the numbers and it'll say each other.
So at t equals 3.14, that looks a lot like pi. Justify your answer. V changes positive to negative. That is my justification.
Well, I'd like to see.
V of 2 pi is 2 pi.
Can you write pi seconds? Is that allowed?
Yeah, you could. Part E, when does the particle change directions? That would be when V changes signs. Well, we just found one of them. That's the same answer. Now, does it change signs again?
No,
That's a little harder to tell, but if I trace, my y is negative, 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 all the way, still negative. Yes, it's all the way, up to 2 pi, it's all negative. So,
cool.
all right, answers are posted. Come see me Thursday during B lunch if you want to go over some more things.